Okay, hi there. My name is Alfonso, and I'm going to explain about Firebase today and how can we incorporate Firebase in an iOS project using Swift language. This is sponsored by YellowPepper. Uh, I said Swift language, but also Firebase supports Objective-C natively, and Firebase was designed for Android and web development too. So that was that. Today, the outline for today. So I'm going to explain about what is Firebase, how can we set up a project in iOS in Xcode, um, and explain about how can we send and receive messages using the real-time database and the rules that we can apply to these messages if a user is allowed to read or write. Also, the same is for the storage database in where we can store images, videos, or rich content. So what is what and why, or the 5 Ws? Who, what, where, why, because. So who is it for? Firebase is for client-side developers. Uh, Main idea is to not to eliminate, but to ease the developing of an application without having to learn all these other technologies or languages or services, and jumping from one to another one and try to connect those together. So that's who it's for. Who is it for? The why use it. Why will we use it? As I also said, is to avoid having the trouble to connect all these technologies together. The current technologies, because the current solution involves choosing and design a database, also choose and set up a server that is accessible through the internet. And the database and the file storage are two different things. And we will need to get a file server for the file storage, and a database server. So those are two things. And then set up a server and create and route those two together with an app server. That's our third server. And then connect that server to our client and then try to route where if a message will go to the database or if an image will go to the storage server. Also, we need for client-side developers, they need to pick up an authentication method. Personally, I never dealt with this issue before knowing about Firebase. So I didn't. Supposedly, it's hard to. I mean, Facebook is not that hard, but trying to set up a server authentic or use a platform for user authentication using email and password, and then also try to use Facebook or Twitter or Gmail and offer all those together to a user and making sure that they don't sign up more than once might be a little bit it might be a huge learning curve for maybe for a junior, maybe not for a middle or not for a senior, but I think that can be a tedious process for either one of those because we just want our users to sign up, and if it's through Facebook, might be better. Also, the current solution, we need to track metrics using Google Analytics and then try crashes using services like Fabric. Also, for example, delivering push notifications or cloud messages to our users involves creating a website and then handling those messages that will go to the Apple APNS or Apple, what is it? APNS, Apple Provider APNS, Apple Provider Notification Services. So connect our website that we didn't create it to the Apple provided notification services and then delivering to our users, handling that. So those are some of the features that the client-side developers depend upon a big team in order to accomplish this. And client-side developers, their job is to design the final app, make sure what is it going to do, how is it going to connect, what information it's going to retrieve, it's going to receive or in display. There's a lot more to it, but I'll just stick with those simple things. Firebase simplifies mostly the contrary of what I said on the current solution, but it simplifies the database, the authentication, the storage, cloud functions, which I don't know if any of you guys use parse, but I didn't. But I had an explanation on what is cloud functions about using parse, which is a code that gets executed, I don't know, depending on events, and then gets delivered back to the client side, or maybe a code that gets executed if a user changed their name in Facebook, something like that. And then we update the name of the app, something like that. Very vague concept. But at least in Firebase, Cloud Functions allows you to execute backend code depending on client-side events. Also, Firebase allows you crash reporting. It acquired Fabric. It just acquired Fabric, the most popular framework for client-side developers. So that's coming to Firebase. Also, Firebase allows you to remove app configuration. It's a great feature, I think, which allows you to modify your app in order to test new features with your current users, or not beta test users, but production users, without having to submit your app to the App Store again. That can become very handy. And it also even helps you or allows you to create your own API, aka like Swagger. So that is the what and why. Now we're gonna go about set up a Firebase project in using Xcode, Swift, and iOS. Yeah. So first off, we go to console.firebase.google.com. We sign up with our Gmail account. If we don't have one, that will be saved for another video. We add a project. Let me see. We add a project, which is adding a project or creating a project in the web console involves. Okay, got it. A project can be distributed to iOS, Android, and web. So all of these three client-side apps can connect to the same real-time database or storage, or can authenticate with the same project. So if I sign up through Facebook or using the web, I can maybe download the app and use the Facebook, and it will have the same. I will have my profile already set up. Going back. We need to add Firebase to our app, of course. Firebase provides a config file, and we need to include the SDKs in our apps. This goes the same for Android and iOS, and then for web, you just have to install a snippet of code at the end of the HTML website. For iOS, as you can see, we just need to install pods or include the pods in our pod file. And we're going to stick with the first three, which is storage, database, and core. Core is for configuration. Storage and database we will explain further. We did this. Firebase database. Something important to mention, Firebase tries to be as efficient as possible. So if the device loses connectivities, the changes are saved locally. When the device connects to a network again, they are pushed and the data is updated across all platforms. Let's talk about the real-time database. Let's see, I have notes here. The data in Firebase console is presented as a JSON object. From client side, this data is sent as dictionaries, at least in iOS. Or yes, dictionaries. The keys of these dictionaries must always be strings, and the values as any other JSON response, as we have seen in the past, can be ints, booleans, strings, floats, or nested objects, and other dictionaries. In order to differentiate users, Firebase uses push IDs for it's an Android method, it's an Android label, and then child by auto ID using the iOS client-side code method. It's an iOS client-side code method, and these are these ones right here. I will provide a link maybe in the wiki page, which explains about how these push IDs are made and the best practices in order to make them unique. So this one, yeah. Firebase arrays are not recommended, but they are possible. But why they're not recommended is because if you store an array, it really gets stored as an object with integers as the key names. Meaning that if I push the array A, B, C, D, E, F, G to the C letter, we'll get the dictionary 0 as the key, A as the value, 1 as the key, B as the value, and so on. But as I said before, they're not recommended, but they're supported. Arrays will be supported if all the keys are integers and more than half of the keys between 0 and the maximum key in the object have non-empty values. And more than half of it have non-empty values. The second part, which is non-empty values, is important, according to my research. So here in the structure and describing, I should place here on top. This is the parent node. Let's call it messages. It's the letters are white color. Are white color. That's why you guys cannot see them, but it says messages right here. The push IDs and explain, and this is the key and value. So yeah, mostly like a JSON. Oh, I do have an example. So yeah, if we send A, B, C, D, they get represented as zeros and ones. But they're not recommended because if we get to delete one of those keys or values, or one of those keys or pair, or yes, they're no longer sequential. They lose their order or they lose their numbers, and then we see 2 and C and 4 and E. So when you download this dictionary or array, supposedly, it will start crumbling apart in the client-side code, and you might and you might have unexpected values. Later on, we'll go on a sample project that I created, and I did post it on the wiki page. But for now, let's go on with the rules, because the database has rules, because you don't want hackers. You don't want other people writing to your database without permission, or writing to notes without permission. You might want to have like an admin panel in your app, or you might want to have pay features in your app. Those are two examples. So you might restrict access of reading and writing to the database only, or if the user has not been authenticated, for example, if they have not signed up through any of the previously mentioned sign up as user authentication methods like Google and Facebook. So the read and write are important. The validate validates if, I don't know, if the user belongs to a certain country, or if the data, or so the validate is usually used with these variables, predefined variables. I was trying to use countries, but let's go with these ones. The now describes the current time in milliseconds as unipox Unix epoch time. Epoch time. I don't know how to pronounce that. So we can use we can set up the validate if now equals certain timestamp, although that doesn't make sense, but yeah, if the current time it's equal to certain time, one of the certain time that we can define on the roles. Moving to the next one, the root, it corresponds to the current data at the root of the database. You can use this to read any data in your database in your rules expressions. So I'll say it again. You can use this to read any data in your database in your rules expressions. Okay. The next one, new data, corresponds to the data that will result if the write is allowed. So again, these predefined variables, we will usually use them with the validate. I'll go with this example right after reading this. The data variable corresponds to the current data in Firebase real-time database at the location of the currently executing rule. The $sign variable, it's a wildcard path used to represent IDs and dynamic child keys. And the out variable contains the token payload if a user is authenticated, or null if the user isn't authenticated. And going with example, so we have, when we first create a project, we're given rules, and then we're given the read, the write equals set up to true. In this example, or on this sample, I have created a parent node, which contains the key chat, string key chat, and then I have given permission to anyone to read and write to this node chat. Something important didn't mention here. Maybe the next one. Let's see. So rules, setting up the true and true. It follows back. If it follows down to the child nodes. So anything below, if you have other features or other folders that people can read and write database to. For example, admin block. So admin block is inside the chat node. So in order for a person to access the admin block, they need to have chat. They need to access the chat first. Okay, let's see. So as I was saying, I have read and the write equals true, and then the admin block, I have set up the write equals false. True is cascading for every child node. False, if I set up the read, the write, and I set them up to false, and I have the write equals true, people can write to admin block. It means that false is now cascading to child nodes. I think that was that. Let's see what else. Perfect. A sample. Perfect. So I have a node or a path called messages that client-side app can write to, or users can write to, presumably, if I give them access to. And every time in my app, I'm sending, let's say it's a chat app, which contains a name, text, and a timestamp. So I have set up the rules for the messages path or node, parent node. Oh, what happened? Yes, parent node, and I have set them up to true. This is recommended for developing purposes. Otherwise, go ahead and use alt not equals null for read and write, or any other type of rules that you want to come up with. I'm using this one because I want all my users to be authenticated before they can write to my app or read from my app. Further down, I'm using the wildcard messages, which evaluates further evaluates what's contained on this messages dictionary, I guess, or nodes, what this node should contain, for example. So I'm using the validate. I could also use the read and the write on the messages inside the messages wildcard. But let's just use the validate. So I'm telling the rule, I'm telling my rules that I want that the messages, which follows the path that I set up on client side, it needs to contain 3 children, and the name of those children are text, timestamp, and name, which goes according to the keys inside the messages, or 2 keys of each of these child nodes or dictionaries. It's a little bit confusing. I mean, it's not confusing, but it just goes back and forth. Also, I want that the values of these child nodes must be a string for the name, a string for the timestamp, and a string for the text. Further down, I want that the name needs to be a number. Oh, yeah. That is not. Yeah, that doesn't make sense, because I'm telling them that it needs to be a string before that, and then I'm telling that it needs to be a number. So yeah, just for showcasing purposes, you can further specify any other thing inside the child nodes. The name must contain, I don't know, the word ABC at the beginning, like a prefix, and then just keep going with the new data. Something like that. So you can further specify the requirements for each of the child nodes, assuming that people can write and read to the main node. Did I have any? Yes. Now we're going to go with storage database, or Firebase storage. In the storage database, you can store large files like rich content, documents, images, and videos, as I previously mentioned. Oh man, hopefully I have sound recording. It was failing me this afternoon. We can upload the uploads and the downloads from the storage database. Try to be as efficient as possible when dealing with low or no connection. So I previously mentioned, when the app or the device gets connection back, it pushes the data and updates any new data from any of those 2 databases, either the storage or the file. Firebase and this type of storages or databases were designed for scaling, meaning the Firebase is considered as a backend as a service. You have a free tier, a paid tier, and a pay-as-you-go to suit your needs of the users in your app. You send a photo to storage, and on the callback, you send the reference of that photo to the real-time database. That's what the picture is trying to show. Because if we're sending a big file, we don't want to store it on the real-time database, because it prolongs, or what was the word? It prolongs latency, or I think so. That's the correct phrase. Yeah. I wish I could say it in Spanish, but I'm explaining to people in English. So if we want to send a picture, we want to store on the main database, on the storage database. If we want to retrieve it, well, we Once we store our picture, we get a reference to that picture in which we can put it in our real-time database because it's just a reference, which is a string. And on client-side code, we can detect this reference and then make a connection to using that URL and then download the picture from that URL. Again, as mentioned at the beginning, a storage database also contains roles. And these have a different syntax than the real-time database, which is a JSON JavaScript-like syntax. This one, I don't know what it is. So if anyone has any suggestions, put it on the comments below and subscribe to my channel. So the types of paths. So let's look at the example on the right. The yellow letters are by default. Inside this, we can start defining the roles. So the match is a keyword. It should be there. What follows after the backslash, open curly brackets, all paths equals star, close curly brackets. That can change by, and it can be in 3 types of path, and that's, yes. So that's the path that we're going to specify a storage database to be. So we have 3 types of paths, which is the single segment, which instead of, we can just, okay, here's my mouse. Instead of having this, we can have single segment, and an example will be images profile pictures.png. And then we can say that the users are allowed to read and write to the profile picture.png if they have been authenticated. So if the user has been authenticated, they can read or write, meaning update or see the profile picture.png. That's a single segment, which just specifies a direct path to the file. The single segment wildcard specifies a path, the path to all the files in a directory. And the multi-segment specifies the path to, there's a directory? No, I meant to say images on the previous one. This one specifies the path to the images and all directories and subdirectories. They also are path, as we have here. The backslash represents the root, of course, just in case. I don't have anything else. Cool, that's it. Now let's see an implementation of how can we do this on iOS and using Xcode, which is the only tool that we have. I don't know why I mentioned that. Okay, perfect. And then let's open Firebase, console firebase.com. Okay, perfect. Did I sign up? Nope. Gutierrez. I created this project. I'm not gonna tell you when, but I did it the morning this morning. I give it this name YellowPepper because it's my favorite project. It's my favorite project. Oh, wow, this is hot. Why is it so hot? But if you're creating a new project, we just add a project, we give it our name, we create a project, and we're showing this. And let's do it again, so you guys can see something else. Corbanca, that's my co-worker's favorite project. currently. It's taking so long. What is with this noise? Okay, did I create it? Perfect. So I received these 3 screens. Otherwise, well, we say not right now. So I'm gonna go ahead, click our Firebase to our app, give it our bundle ID, com.yp.corebanca, and then register the app. We download our config file, plist file, proper list file, and then we're given instructions that we need to solve the SDK using the pods. And then we just go ahead and add init code in our app. So that's the basic setup given by our Firebase. And we have this, which is the previous screen. I'm going to keep using the one for About Pay that I created before. Now we're going to go to database. You can see a bunch of things here. We have authentication, database. Let's delete this. Delete. And let's delete. So we're going to use, today we're going to use database and storage. Let's delete the files here. I previously did this. So first we're going to use the data. Okay. Yeah, I just wanted to clear up this. So in our code, I created this sample app in which I just send a message no, as I use on the slides. I send this no to a real-time database in Firebase, and I retrieve it. Maybe I can show you this. Oh, I have added the Google Service Info plist file already in this app. I just have to right-click, add files to Firebase, and locate it on the download folder. Our app consists of text field, of a button, of a UI image view, and a label. Text field is in order to send a string value matched with a key string, and we're going to use the send button in order to send this. Also, the UI image is going to be used to display the image that we have stored by using just the send button, and the label is going to be used to display the text that I previously sent in the text field. So I'm sending something, displaying it on the label, sending an image, displaying the image view. That's my app, popular app. But before we do that, we need to configure our app to connect to our project in the console. After we have included our Google Service Info.plist, we can go to our app delegate, and on the function application to finish launcher with options, we only need to call fireapp.configure. And but first we need to import the framework, import Firebase. Again, this is Swift. You guys can do it on Objective-C. I just got used. I don't know. My first language to go is Swift. That's another video. So we have already, and the fireapp.configure will look into our project for the Google Server Info.plist and start establishing all the proper connections. As you can see, I have the storage bucket, I have the bundle, where is it? The Google app and the Google app ID and the database URL. This must match this one. Yes, Firebase and FirebaseIO.com. Correct. So that's there. So we have configured our Firebase app delegate. And here, let me walk you through our properties. We have a reference variable, which is of type Firebase data reference. Then we have an array of data snapshots in which we're going to use to collect the nodes that we concurrently capture from the real-time database. Message lane, it's okay. The storage reference is to establish a reference to a storage database. The image cache doesn't matter. The placeholder image doesn't matter either. Don't know why I'm including this. The reference handle, I will further explain on it once we get there. In the display name anonymous, I don't think I used that one. Also have set up the outlets for the text view, the label, and the image view. In order to update those once we have successfully retrieved the image and the node. My beauty load I have called configure database and configure storage. If we go to configure database, here it is. So we need to get a reference to our database. We have the URL in our Google service.info plist file, and we have called our fire app.configure. Now we can call, we need to import, of course, we need to import the Firebase framework or pod. So we need to get the reference to our Firebase database. We do this by this line of code. That reference sounds very simple, straightforward. So we get the reference in order to start creating parent nodes and child nodes and stuff. So we got our reference. Now we need to send a message using this reference. On my UI, I have defined a text field and a button. Well, whatever you write on the UI, on the text field, and once you press the send button, I have set up, this is the button is an action which should do, will do, create a dictionary of type string for the key and any value for the and type any for the value. Right now it's currently empty. I've initialized it to be empty. This is a variable, and then I can modify. I'm gonna assign it the key message, and in the field I'm gonna assign it the value of the text field. And in the value, I'm going to assign it the text of the text field. If there is no text field, I'm going to give it a default value. Or if the user hasn't write anything and it just still press the send button, I'm going to give it a default value, which is message between brackets. And then I'm going to call the method sendJSON, which which has a param that's named data of type dictionary, and we can see it down here, which is this one. In order to send the JSON, we use a reference .child. So the child creates the parent node because there's a bigger. So this is actually the parent of everything. About pay / something. It's currently set up to null. So I'm going to create a child of it by calling reference.child, and then I'm going to call child by auto ID. These are the push IDs that I previously mentioned. These are used to differentiate one user in iOS or many users in iOS from another user in Android or from many users in Android. And then we're going to set the value of this child message that has a push ID. And the value is going to be the data that we previously set to be, that's going to contain a key that is message and a value it's on in the value that it's on the text field. Closure ahead. This method setValue also has there's also another method setValue with a closure included, in which we can detect if we wrote, if the writing to a database was success or if there was an error. So we call here data, and then we have the error, and then we have the reference, database reference, just to verify. I mean, you can do whatever you want, just to verify if we wrote to the specific database to compare, for example. But right now we're going to keep with just setValue to data. So here I'm sending my dictionary to the database. Here I'm going to send the image, but let's comment that for a second and let's test it. This app came out good because I didn't test it before I show it this morning, because I thought it might be a one-time successful app running, and then the next time could crash. So I just risk it. So we're gonna say hello world, and I think we're gonna press send. Nothing on the console, unable to access privacy, although we don't have the closure or the block, and we still should get a permissions denied. If we didn't set up our database rules, which by default, the database rules are the user needs to be authenticated. But I did set them up from this morning. As if you guys remember, there was nothing here, there was just about pay. Now we have messages, and now we have strange little words, which is the push ID that we call here child by auto ID. And then if we open this, we can see the key message and the value hello world. Going back to the rules, this morning I set them up to true and true. Again, this is for developing purposes. We just have to hit publish. Developing. Or you guys can do auth not equals null, authentication not equals null. And then the same for the right. Get the idea, right? Or any other type of rules you want to apply to. So right now we're just gonna leave it like true and true. So we're able to write to our database. Yes, if you guys are running the app, you can see this live. That's why it's called real-time database. Real-time. And a new node was added, real-time. Cool. Now we have reading to our database. Now we have writing to our database. Now we need to read. If you guys notice, real-time has been displayed also here on the UI label. So how can we read? On the same method that I call configures database, I also added this piece of code, which is a database observer. So we get our reference variable, then we listen for the child messages, and then we observe if a child was added. Also, we can observe if a child changed, was moved, or was removed, but right now we're just going to keep added. And on the block or on the closure, we're going to get a snapshot of this child or this JSON object. We're going to append it to our array, message array, and then we're going to we're gonna break it apart. Here I'm looking to the array, and then I'm looking for the last self, the message to the count minus one, the last node that was added or that was registered, and we're gonna call the dot value and as string. What's this? We're casting it. If we are getting on Swift, if we're reading a JSON, we need to cast those values. It can be inferred to, I guess, but it's recommended to cast JSON values that you know the type of. And then we're assigning to the variable snapshot. In the snapshot, so we get our dictionary, and then we're gonna look for the key message. That is this right here. And on the key, the if let, it's about making sure that this is not a nil value. There's another one which is a guard statement. But if the message, if snapshot, if the dictionary, or if the key message exists, assign the value to message constant. Let is for constants. Is to define constant variables. Then assign the value to the message constant. Then we're gonna update our text label with the message value, and we're gonna do this on the main queue because the observer is it's a network code. So yeah, that's why you guys see everything I push or I send as a JSON, pushing to Firebase, and then pushing to Firebase because we are updating it here on the main queue. Now we're gonna send a picture. I wonder if I've been sending the picture. Oh no, okay, perfect. So I'm using the same method, send JSON, to send my picture, which I previously commented. I have added a picture to the assets folder, color reports. I think you guys can see like some sort of diagram or yeah, something like that, and then color reports. So the if let again is to make sure that whatever I create here is not a nil value, and assign it to a photo constant. So I created an image with the name that has the string or name reports, send it to constant photos, and then make that image a JPEG representation, which I assign it photo from the previous constant, and what is this value for? And the compression quality 0.8, and then assign it to a photo data constant. So make sure that this is not nil, make sure that this is not nil. Use this constant inside this creation object, then assign it to the constant photo data. If both of them are not nil, then use the function send photo message and pass along the photo data constant. This is done here. So the send photo function takes a data object and creating the path of the image and telling them that it's going to be a directory, which is going to be called yp_photos, and then telling them that the name of it, or it's going to be of this photo data, it's going to be reported to a JPEG. Always set the content type. In this case, we're sending it to image/JPEG in the storage metadata. So create the constant metadata for base database. The metadata and metadata the content type equals image JPEG. So once you have set the metadata content type, we're actually gonna um, send it. So we get our storage reference, which I didn't mention before. Well, I think I did. So on the view below, I call configure database and configure storage. The configure storage is pretty much the same. It's very looks a lot like the configure database, which is assigned to our variable storage reference. It's going to be equals to fire storage, the storage dot reference. I think I didn't place this together. Should have placed them together. So one is fire database and the other one is fire storage. So that's that. Just trying to break them apart. And then so we use our storage reference. We create the child as we did for the JSON. And we're passing on the image path that I previously gave it, and we're putting the photo data, and we're passing also along the metadata. And if this method gives us a block or a closure in which we can capture the image URL as I previously mentioned on the slide. And if there was an error sending this data, we first cut up if the error, if an error exists, or if an error doesn't exist, or it's equals nil. So if the error equals nil, if there's an error, or if the error is not equals to nil, if the error is not equals to nil, meaning that there's an error, just print error uploading and the type of error and return. Don't keep going. And then we're going to use the same method, sendJSON, because the metadata gives us an image URL reference of type of reference, which is of type string. And then we're going to use the sendJSON to send a dictionary which contains the key image URL and the metadata, the path, the description, which is the actual URL. So we call save the storage reference the child that. So yeah, let's stop this and run it again, because I uncomment this piece of code, which is where we create our image and we convert it to a data object. And okay, so image, sending an image. So currently it's going to send the node, and it's going to send the image, sending image. So we're going to see let's see if we can display here. So we must, let's go to storage. Storage has, okay, the rules that I previously explained. Let's check out what those are. So read write if request all equals null, meaning that I don't want the users to be authenticated. So currently we don't have anything. Let's press send. I know it works. Send the image. Nothing happened. Why? Do I need to refresh the page? Okay, so storage is not real time. The database is real time. So I was able to send the image. This is my directory, YP photos, and then I have my image, the JPEG. If you tap on it, you can actually see a graphical representation. Apologize if I mumble. It's a little bit late and people are sleeping. So we're able to send the image to storage, but also we were able to send a dictionary using the sendJSON function to our message node. So inside one of the child, the last child node from message should be a key that is image URL with the metadata.path.description, which is a reference to that image that we just sent. Let's check it out. Whoa, we have sent a lot. We keep sending. So stop this. Why? I'm calling over and over again. That didn't work like that this morning. I need to check that out. So all of them has the same one. Yeah, I don't know what happened. So we have the image URL, and then we have the reference to that image, the URL reference. And so now we need, so our client-side code now needs to build that image based on this reference. So on the method configure database, remember that we added a database observer. So your server checks for every child added, meaning that all of them should be on the message array, because it's a cluster that keeps running over and over as long as your view controller is displayed. Otherwise, if, as you guys can see, no. We need to initialize our observers in the init method once our view controller goes off the screen. Otherwise, we will keep adding new nodes to our local storage or our local array, and that might consume device memory, or whatever happens after. So right now we have a lot of snapshots in our local array. So here I check for the key message, and now here I'm checking for the image URL key. If there is one, assign it to a constant image URL, and then use the file storage, the reference for URL, image URL, and that data with maximum size in 64. It's basically building the image using the .data method. Is it? Downloading. It's downloading the image data. No, it's not building. It's downloading the image data. If it was downloaded successfully, you guys can include like a iflet if there was an error, like we previously did. But if I'm assuming, because I know that there was an image with that URL, so UI image init with data, scale 50, and then update our UI in the main queue. So we assign the message image constant, which is the image that we downloaded from the blog, and assign it to the image view on the main queue. So meaning that, so since this code was not commented, it means that it was running at the time that we send our image or we send our node. Our UI is displaying the image currently. And there you have it. And this one, okay. Just stop, okay. I think it keeps sending the data, don't know why. So yeah, we send a message, and currently the message also sending an image, local image. Then we're updating the label, and we're updating the UI image view based on the observer, and getting the values for those dictionaries. I think that was an hour. Hopefully I recorded with video, with sound.